All right, gang. Math 5500. I want to hop on here real quick and demonstrate discussion forum post number one. That was intended to be super straightforward. In fact, very easy. But sometimes things can be so easy that we overcomplicate them, overthink them, and a few of you did. So I just wanted to demonstrate this and show you the approach that I intended for you to take. Now, I've already done a few things. Typically, I don't get my working directory because I already know what it is because I've done this so many times. But I wanted to demonstrate this because I know that I realize that a few of you are still learning R. The next thing I did is I set my working directory for the desktop because my file right here, bodyfat.csv, is on my desktop. So I need to tell R where to go get my file. The next thing is I import body fat into R, and I'm going to call that data set data because I'm not very creative. And then I'm going to attach my data so I can run operations on the data set. The next thing I like to do is I like to look at the top 5 or 6 cases, and I can do that by going head data. So I can see here, well, if I go length, just do a little bit of teaching here, whatever variable I want, I can see that I have a sample size of 20 people, 20 cases, and I have 1, 2, 3, 4 variables. Now, the intent here is to create a model that can predict body fat from mid-arm. And I'm going to go ahead and look at the summary of the model. All right. So one of the questions asks to find the test statistic and the p-value for the slope. Well, that information is found on this line right here. The 0.1994 is the coefficient estimate. The standard error is 0.37. The test statistic is 0.611. And the p-value is 0.549. Again, this line gives the test statistic and the p-value for the slope. Now, a few of you got confused and reported this information down here. In the simple linear regression world where we have one predictor, it turns out that this line and our coefficient line will be the same. But the F statistic is actually the model diagnostic. When you have one predictor only, the model diagnostic and the coefficient are going to be the same. So the 0.549 and the 0.549 again have the same p-value because we only have one predictor, but notice that the F statistic is different. Well, it actually turns out that the t-distribution squared is the F distribution. So if we take 0.611 square it, we get the F statistic. So what should you take away from this? What you should take away from this is when I ask for the test statistic, the p-value, and the confidence interval for the slope, well, I'll tell you about the confidence interval in just a second. We have tunnel vision on this line right here. Again, in the simple linear regression world, one predictor doesn't matter. It's the same thing. The p-value is. But these are the two that we should report. All right. Now, I ask you to come up with the confidence interval for the slope. That's easily found just using the CONFINT command in R. So the slope again is mid-arm. So the 95% confidence interval would run from negative 0.49 to 0.89. Now, the next thing, we switch gears to the correlation. To run the correlation, we use what's called core-test, and we put our x variable first, which in this case is mid-arm, and we put our y variable second, which in this case is body fat. Now this is kind of cool because this gives us our test statistic, degrees of freedom, and p-value, and it gives us our 95% confidence interval, which would range from negative 0.32 to 0.55. Now you'll notice something kind of cool. Our test statistic for the correlation coefficient and the p-value for the correlation coefficient is the same as the test statistic for the coefficient. Again, in the simple linear regression world, that happens. Of course, once we move into multiple regression, we'll completely get rid of correlation because it won't be any benefit to us except for some sub things, sub analyses that we run. So the correct response for the slope, we would have our test statistic equal 0.611. Our p-value would be equal to 0.549. And our CI would be equal to negative 0.49 to 0.86. Don't want to make a typo. Same thing for our correlation coefficient. Test statistic is going to be the same. Our p-value is going to be 0.549, and our CI will be equal to negative 0.32 to 0.55. So guys, that's all you had to do for this assignment. So take care. I hope this helped.